Hello Year 12 and welcome to the final episode of Mathematical Mowbray Movies. There's no new content in this video. The idea is that it's just some tips and tricks to help you go well in your trigonometry topic test. So I thought I'd start with a little trick of my own. I'll just give these cards a bit of a shuffle so that you can see that there's no dodgy stuff going on here. So if you just have a look through, oh, there's a joker. If you just have a look through, you can see that they're all pretty well shuffled here. Okay, I'll give them another shuffle just so that you're satisfied. Okay. Now this trick's called the power of 4, so I'm just going to cut the deck wherever it happens to be cut, so there. The idea of this trick is that I use my mathematical powers of deduction to work out what the fourth card in this pile is by looking at the fourth card in this pile. So I'm just going to count 1, 2, 3, and I'm going to have a look at this card. Okay, and so I'm now going to tell you that based on my knowledge of that card, the fourth card in this pile will be the ace of, just trying to think, clubs. Let's have a look. 1, 2, 3, let's turn it over, 4, smashed it. See if you can work out how I did it. There's my first little trick for the video. Now I'm going to give you some more maths tricks. So, the first little tip or trick that we're going to have a look at is this one, that when you're given a question, you need to fill in as many angles as you can. Now there's lots of different little relationships that you can use to work out some of those angles. So it might be that they add up to 90 degrees, it might be that they add up to 180, it might be using the fact that all of these angles together would add up to 360. It might be using that Z rule, the alternate angles rule. It might be using the co-interior rule, where these two angles add up to 180. Or it might be using the angles in a triangle adding up to 180. So there's lots of different rules there that I'm going to point out as I just show you these little questions here. So work out as many angles as you can. Well, let's have a look. I look at this question here and I can see that this is a right angle. Now I know that the angles in a right angle add up to, they're complementary, they add up to 90. So here's my question. I've got this little one here that's 70. So these two have to add up to 90. So what must this one be? Well, 20 plus 70 gives me 90. So I've worked that one out. Now I know that these two here are 70 and 30, and I can see that here's another triangle here. So I'm going to use the fact that angles in a triangle add up to 180 to work out what this angle must be. If this is 70 and this is 30, together they add up to 100. So this one here must be 80 for these three to add up to 180. Now I'm going to use that fact to work out what this angle must be. Well, these two angles are on a straight line here. So I'm going to use this rule, that supplementary angles add up to 180. If this one here is 80, I have to think, well, what must this be in order for these two to add to 180? So this one here must be 100. And then finally, I'll work this one out, and I'm just going to get you to have a go at working that one out. Good luck. How did you go? Fingers crossed you worked out that, well, this is a triangle here. These three must add up to 180. This one's 100 and this one's 20, gives 120, so this must be 60. Alright, here's another one here. Again, fill in as many angles as you can. Well, I'm told that this one here is 115. I'm going to use that co-interior rule, this one down here. This one says that if angles form like a U, where these two are parallel, then these two inside angles, the ones on the inside of the U, add up to 180. So here here's my U, this one, and this one. I know they're parallel because they're both pointing north. So I'm going to use that fact to work out what this particular angle must be. If this one here is 115 and they have to add up to 180, I'd be looking at, well, what's 180 minus 115? So I'd be doing that and saying, well, that must be 65 degrees. So this one here must be 65 degrees. Now I'm going to look at what else I can work out on this diagram. If I know that that's 115 and I know that's 35, I can work this one out, because I know that these three angles must add up to 180 since they are on a straight line. So I'd say, well, what's 115 plus 35? 115 plus 35. If I add those two things together, it gives me 150. And I know that these three have to add up to 180. So I know that this one must be the difference. So it must be 30 degrees. Now I'm going to use the fact that the Z rule, so the alternate angles rule, to work out another angle here. So I'm going to work out this big angle here. So the Z rule, or the alternate angles rule, says that these two angles, here and here, are equal. So this one would be 70 in that case. So looking over here, I'm going to say, well, it's a little bit hard to see because I've drawn quite a bit on it. Let me get a different texture. Yep. That here's my Z here. Can you see it? It goes like this. Okay, where that's 115. So here's this, and here's my Z. So that tells me that this one here must be 115 altogether. Now, I'm going to try and work out what this little one here is. So this, just the one in that triangle. If I know that this one's 30, again I can use my Z rule. It's kind of a Z on its side here this time, but can you see the Z there? I know that this little guy here must be 30, since those two have to be equal. If I know that this whole thing is 115, and this little part of it is 30, then I can work out that this one here must be the difference between the two. So it must be 115 minus 30. And of course 115 minus 30 would give me 85. So this here must be 85 degrees. So last but not least, I'm going to try and work out what this angle here is. My diagram's getting a little bit messy, so I'm just going to redraw that triangle. So it kind of looks like this is my triangle. I know that this here is 30. I know that this one here I've just worked out is 85. Now I'm going to use the fact that the angles in a triangle add up to 180 to work this out. So I'd say, well, what is 85 plus 30? So 85 plus 30 gives me 115. So I'd say, okay, if those two add up to 115, what must this one be in order for it to add up to 180? So I'd do 180 minus 115, which gives me 65. So this little angle here must be 65. That's that angle, 65. So if I wanted this little guy in here, if I know that's 65 and I know that's 30, I know this is 35. So you can see, from just those couple of angles in these diagrams, I could fill in heaps of information, and you need to be able to do that using all those different rules that I mentioned. Work out as many angles as you can. Of course, this one, you'd be dividing the 360 up by 1, 2, 3, 4, 5 to work out what that angle is. I think that's the only rule that I didn't use otherwise. So I'd say 360 divided by 5. Okay, second tip. Don't confuse angles of elevation and angles of depression. Angles of elevation and depression always go from the horizontal. Depression means to go down. If you depress a button, you push it down. If you're in the pits of depression, you're feeling sad or down. So it's from the horizontal down to whatever you're looking at. So this is my angle of depression. Of course, in my triangle, which is always what these questions are about, this triangle, I'd need to work out one of the angles in there. And I can do that by using the 90-degree rule. If I know that this is, say, 70, and I know that this is a 90-degree angle, then I could work this one out, like from the last video, by doing 90 take away 70 to give me 20. Alternatively, I could use that this is a Z here, see that Z there, to say if this is 70, this must be 70. Either of those is fine. Angles of elevation are measured from the horizontal up, because if you jump in an elevator, no, it doesn't quite work because elevators go down. But if you elevate something, you go up. So this is the angle of elevation. Angles of elevation naturally fall within the triangle, so that's nice and easy. Angles of depression, you need to do a little bit more work. Next little tip is use the right formula. I've shown you this diagram about 1,000 times, but you need to have it clear in your mind that when you're faced with a triangle, you've either got right angle triangles, in which case you use Pythagoras or SOHCAHTOA, or you've got your non-right angle triangle or obtuse angle triangle, in which case you have to use the cosine or sine rule. This here is your formula sheet, or what you get on your formula sheet. So I just want to point out, sorry, that probably made you feel a bit sick with that moving. There you go. I just want to point out a couple of things on how you can help yourself remember which rules to use. The whole top section of your formula sheet here is in reference to right angled triangles. So these are all right angled triangle rules, SOHCAHTOA. Now they don't give you in your on your formula sheet the other right angled triangle rule, which is of course Pythagoras' theorem. So I would just put Pythagoras' theorem somewhere up here. You might want to do a little diagram if you want, it's up to you. A, B, remember C has to be the hypotenuse. Just as a little reminder so that I've got all my right angle triangle stuff together. So when I see a question with a right angle triangle, I know, think up here, what am I going to use? Now remember, Pythagoras' theorem involves 3 sides. So if you see a question and you're dealing with 3 sides, that's what you're going to use. Whereas SOHCAHTOA involves 1 angle and 2 sides. So if you've got a question that involves 1 angle and 2 sides, you're going to be thinking SOHCAHTOA. These ones down here, of course, are our non-right angle triangle ones. Non-right angle triangle. So the first one there is the sine rule. We don't use the sine rule in this form. We just don't worry about that one on the side. We just use it using with these ones. So in the sine rule you can see here that I've got 2 sides and I've got 2 angles. So you're going to use the sine rule if you get a question that has 2 sides and 2 angles that you're dealing with. And of course remember we use it in its flipped form if we're trying to calculate the angle. The cosine rule down the bottom, you can see it's got in it 1, 2, 3 sides and just 1 angle. So you're going to use the cosine rule when you're dealing with a non-right angle triangle that has 3 sides and 1 angle. So you can obviously use that. This of course in the middle is my area formula. Area is pretty straightforward because if you get a question that asks you to work out area, you are going to have to use this rule because there's no other rules that you've learnt. The sides ones and the angle ones are a little bit trickier. So if you've got a question about area, go straight to that guy. So here's a question. If you're given all these different questions, which rule are you going to use? So I'm just going to talk you through them. Here I've got 3 sides, 1 angle. I'm trying to work out the angle. So straight away, 3 sides, 1 angle tells me cosine rule. And I'm trying to work out the angle, so I'm going to use the form that looks like this. Cos theta equals a squared plus b squared, etc. Okay? This one here, right angle triangle. Straight away my brain goes Pythagoras, SOHCAHTOA. 3 sides here that I'm dealing with, no angles. That's going to have to be Pythagoras' theorem. Then I have a look at this one over here. I've got 3 sides and 1 angle, not a right angle triangle. Again, this will have to be the cosine rule. And I'm trying to calculate a side, so I'm going to use the form that looks like this. Okay, minus 2ab cos c, etc. Here, right angle, bang, I'm going to have to use SOHCAHTOA or something like that, Pythagoras. I'm calculating an angle. Pythagoras is out of the question, I'm going to use SOHCAHTOA. And I've got a hypotenuse here and I've got the adjacent angle, the one next to it, adjacent hypotenuse. I'm going to use cos for this question. Over here, 2 angles, 2 sides. As soon as I see 2 angles and 2 sides, I need to think sine rule. I'm calculating a side, so I'm going to write it out with the sides on top. This one down here, find the area. Well, it's the area one, so I'm going to have to use the area formula, half AB sine C. Over to this last one here, 2 sides, 2 angles, I need to think sine rule. I'm calculating an angle, so I'm going to use the form where we've got sine A on top and sine B on top. Now, I know that feels hard and confusing, but you've got to get good at that. So maybe watch this bit of the video again if you're unsure, so that you get really good at using those formulas and working out which one to go with. Next little tip, think backwards, then work forwards. So saying this question here, it says find the area of the triangle. I'm going to say to myself, I need to use the area formula. half AB sine C. Now if I want to use the area formula, I need two sides, and remember I need the angle between those sides. So I look at my triangle and I say, rats, I don't have that. I have these two sides, but I really like another angle. I'd like this angle here if I'm going to be able to use my rule. So I think to myself, how am I going to work out this angle? So if I make this angle theta, the one I want to work out, well, straight away I can see that I've got 1, 2 angles and 1, 2 sides. So I'm going to need to use the sine rule first. So in this question there's going to be two applications. I've looked at my question and said I need to use the area rule. But before I can use the area rule, there's a step before that, and that is that I'm going to use my sine rule to work out the angle. So I'm going to do that, and then once I've done that, I'm going to move to my area formula and use half AB sine C. Okay, that's what I mean. Think backwards, what do I need first, then work forward. Let's do another question like that. This question says find the length of AB. So this is a radial survey here. So I can look at this question, I can see length, so I'm going to have to think one of those triangle formulas. Well, here's the triangle that I'm going to be dealing with. Okay, I know that's 25, I know that's 71, I'm working out that. What am I going to need here? I'm going to need the angle opposite in order for me to be able to use the cosine rule. That'll be three sides and one angle. So, before I can work out the length and use the cosine rule, I'm going to have to do a step before that, and that is that I have to work out theta. So I do that by using my bearings. So I'm told that this is 45, and your stupid teacher forgot to tell you that this one here is something like 320. So you'd work out this one to be the bit that adds to 360, so it's 40. So this here is 80. Then I'd use my cosine rule. So I've worked out theta, now I can use my cosine rule. Again, you've got to think backwards, then work forwards. Last example of that, Aloa's angle of elevation from where she's standing to a Christmas decoration is 32 degrees. Her angle of elevation to the star is 70 degrees. If the star is directly above the decoration and Aloa is 2 metres from the tree, calculate the distance between the star and decoration. So I'm trying to find that there. So I'd look at this question and go, if I want to calculate that bit, I'm going to need to know this whole height, and then I'm going to take away this height. So if this was 10 metres and this was 5 metres, I know that this must be 5 metres. So I say to myself, how am I going to do that? I've got to do that subtraction last, but before that I'm going to have to work out this height and this height. So to do that, I'd see that I've got two triangles here. I've got the big triangle with the angle of 70 degrees, and that's going to give me the full height here. I know that Aloa's 2 metres away. And then I've got this smaller triangle. Again, it's got a base of 2 metres, but it goes up here and across an angle of 32 degrees. So I'm going to work out each of these using, well, I'd use here right angle triangle, opposite and adjacent, tan in both cases. Then I'm going to do my subtraction. So that's the step I have to do first, is use tan. Once I've used tan, I can then do my subtraction. Alright, next tip. Substitute correctly. So say, for example, in this question, you're asked to find the area of this triangle. You know that the formula you have to use is half AB sine C. Now, I guarantee that there will be a bunch of people who will look at this question and go, okay, area of the triangle, 515. I'm going to whack them in. So they're going to go half of, they'll just choose whatever they want. They'll probably go with 5 because they'll remember I need a side. But then they'll go, I don't have another side. I'm just going to go with 100 or 15. So they're just going to whack it in. And then they'll put in probably the other angle or something like that. So they're putting the wrong things in. Okay? Now in this question, again, it's a little bit tricky because before I can work out the area, I actually need to work out another side. So you can see I've only got one side here. So here, before I can work out the area, I'm going to first use the sine rule because there's two sides and two angles. I'm going to use the sine rule to get x. Once I've got that, I'm then going to substitute into my area formula. Let's just say, hypothetically, that I got this to be 12. I don't know if it is, so can't guarantee that. Then when I'd substitute in, I'd go, okay, here's my area formula. I know that these are my sides, 5 times 12. Again, don't just go whacking in any old angle. I need to put in this angle because it's got to be between the sides. Well, I need to work it out. 100 plus 15 is 115. So to make it up to 180, this will have to be 65. So it's going to be sine 65. So don't just go throwing any old thing into the formula. Make sure you take care and get it right. Second last tip says draw or redraw diagrams or parts of diagrams bigger and clearer. This question says calculate the length of AC. Well, I've got this little tiny diagram here that's not going to be much use to me. I can see that to get AC, I'm going to have to work out what this bit here is, but it's all going to be too tight and messy. So if I'm trying to work out this, I'd go, okay, let's just draw this a bit bigger so I can see what I'm actually doing. Then I'd say, right, I've got 14, I've got 55, this is 11, this is 32, and this is 50. Okay, let me have a look. I'm going to need to work out a few things here. This is what I'm trying to work out, because once I've got that, then I can add them together, the x and the 11, to get the full length of AC, that full length along there. So I'd say, well, how am I going to work that out? Well, I'm going to need to know some sides or some bits and pieces in order for me to do that. So I'd be saying, okay, I'm going to need to go use my 14, my 55 and my 11. I'm going to use these three to work out this length first, so you might call that A. So I'm going to use those. This is that triangle. So again, this is what I mean. Draw out different parts of it so you can see what you're doing. 14, 11 and A. So I'm going to use 1, 2, 3 sides and an angle, the cosine rule, to work out what A is. Then once I've got A, then I'm getting close to things being good because I can see that here in my next triangle, again, I'll just make up a number. Let's just imagine that A was 10. Once I've got that 10 and I know this is 50 and I know this is 32, I can then use my sine rule because I've got two angles and two sides to work out x. Once I've got x, of course, let's just again totally make it up and pretend it was 4. To work out that full length, I'm going to do 4 plus 11. So working backwards again, that whole idea of thinking backwards to work forwards, and of course drawing the diagram bigger and then drawing the little parts that I'm working on at any one time. So lucky last tip. Last tip, here it is. I know you're sick of this video probably, and here it is. Practice, practice, practice. Nothing fancy. Just do things over and over and over again. Ask for help. Send me any questions that you've got and I'll send you a little video. And then you will be sure to do well. So practice, practice, practice. All the best. The last question that you got to do, or the only question you really have to do in this video, is to tell me what you are aiming to get in this test. What percentage are you aiming to get in this test? All the best with this test. I think you've worked really well. Good luck.